Okay? What form is it in now? Anything else? And vertex. Good. Okay, so I want you to take a second and I want you to just find the key features that you can just from those. Okay, so basically everything but x-intercepts, increasing and decreasing, right? So take like a minute or two and I want you to just find the y-intercept, the axis of symmetry, vertex, domain range, just from knowing that that's the standard and the vertex form, okay? So take a couple minutes and do that, all right? Again, don't try and do the factored form on this one yet, okay? Because the factored form on this one's weird. So just answer what you can. It looks like almost everybody's just about done with that. I'm going to wait just another 20 seconds. So I told you guys to hold up on the factored form, which means we can't do the x-intercepts. We can do vertex. Don't worry about the x-intercepts yet. This one's really weird with x-intercepts, so you'll want to wait. Okay, looks like most of you guys are ready to start trying the x-intercepts on this one, so let's do what we can. So 0, 4 is my y-intercept and my vertex. X equals 0. My domain is R. This one's going to be concave up, right? Okay, now let's talk about the factored form on this one, all right? It looks like it should be the cool factoring trick like on the last one, right? But it's not. Here's why. If I'm looking for two numbers that add to 0 but multiply to 4, that's contradictory. Because if I need them to add to 0, doesn't it make sense one of them will have to be positive and one negative? But if one's positive and one negative, how can they multiply to be a positive number, right? So I just want you to pause for a second, and I want you to remember back last unit. If I were going to find the solutions of this, which we've talked about, the solutions are the x-intercepts, right? If I were going to find the solutions to this, what would I set this equation equal to? What would I set this equation equal to if I wanted to find the solutions? 0. Then I would solve by taking square roots, right? So I'd minus 4. X squared equals negative 4. Square root. What kind of numbers are the answers to this going to be? I. Okay, I know it's been a while. It's been since Unit 2. Does anybody remember the definition of an imaginary number? It's okay if you can't remember. I just want to see if anyone can remember. Unit 2. What is the definition of an imaginary number? I know it's been forever. I'll tell you. An imaginary number is an ungraphable number. Numbers I can't graph. So how do I graph 2i? I can't. So what do you think that's going to look like on the graph? Have you guys graphed this one yet? Huh? Yeah, there's no x-intercepts. This is how you can tell. If you graph it, it looks like that. So where are its x-intercepts? Doesn't have any because they're imaginary. They're not graphable. So for factored form, we would write imaginary. And for x-intercepts, we'd write none. Because it has a factored form, I've actually made you guys factor ones like that before. We just don't need to anymore if our goal is graphing. I've had you guys, I know it's been a while, but I've had you guys take ones like that. I'm just trying to jog your memory. Change the plus to a minus and negative, square root each of those, and then you guys did this. Anybody remember doing that? Right? But we don't have to worry about getting, so it has a factored form. It just is an imaginary factored form, right? And there are no x-intercepts. So that's kind of a bummer, right? Because now I'm trying to get 5-point graphing, and I even have less points than I had on other ones. But that just means I'll need to plug in 2 points instead of 1, and then mirror image both of those, okay? Did anybody already plug in 1? What'd you get? 5? Okay, then I can mirror image that here. Did anybody plug in a 2nd point? Anyone else? Do I need to give you some time to do that? Okay, take a minute and plug in a 2nd point and finish out range increasing and decreasing. Brandon? Perfect. 2, 8 is correct. So there's my graph. Increasing right of vertex. Decreasing left of vertex. And then my y is greater than or equal to 4. Questions? Okay, there's only one more type of special feature I need to get through with you guys today. And I'm just going to get you started, and then I'm going to have you guys try most of it on your own. You can skip this one, okay? And we're going to do this one. Okay, so I'm going to give you a couple hints to get started, and then I'm going to give you guys some time to look at it, okay? What form is this one in? Hint, it's 2 of them. Okay, so think about it. What form is this one in? And my hint is that it's in 2 forms right now. Lydia? You got it. Good job. It is in factored. If it helps, think of the factored like this. Okay? And it's also in vertex. What's the extra box if this is supposed to be vertex form? 0, yeah. Okay, so if this is both factored and vertex form, then that should tell me that my vertex is going to be the same as my x-intercepts this time. I reviewed how to FOIL one of these out on example 1 in your notes, so you may want to go back and look at that to get it to standard form, but I'm going to give you guys a couple minutes to try this problem, and once we go over the answers, we're done for today. You guys are doing a great job, okay? So I'm going to walk around and help. So finish this one out. We'll go over the answers, and then we're done, okay?